intake system which is coupled with screens and trash racks, which are useful to filter debris, because debris they should not go into penstock, because if they go into penstock, they will end up by creating problem to turbines or the whole system. That's why we have those racks and screens, trash racks to filter debris. This is a very important, and we are going to see that it should be maintained when we will reach the level of maintenance. So after that, we have a penstock, which is a pipeline or a channel that transports water from the intake to the turbine. And the channel or the pipeline can be made from steel, from HDPE, or it can be also made from concrete based on flow pressure and the budget which is available. Because concrete penstock is generally expensive, but live long. So we have to see what the budget is available to see the type of penstock and the material to use. And it must be designed to minimize frictions and energy losses. At this level, we have some losses which should be avoided. So after the penstock, we go to the turbine. Water channeled with penstock is taken to the turbine. The turbine which converts kinetic energy of water into mechanical energy. So the turbine is going to rotate, and it is linked to the rotor of the generator, and the generator will produce energy. So at this level of turbine, we have generally two types of turbine. The impulse turbine, which for instance can be a Pelton turbine or a Targo turbine. And these, they are for high head and low flow sites, because when the head is high, even if the flow is low, when you multiply the two, we can have a considerable energy potential. Or it can be also a reaction, or it can be reaction turbines. And examples of reaction turbines, we have Prentice turbine, we have Kaplan turbine, which are well indicated for low head and high flow. If you have sites with high flow and low head, you have to go for Francis or Kaplan turbine, or generally for reaction turbines. After that, we have to see the conversion of mechanical energy from the turbine into electrical energy. And there we have a generator. So this design should be done based on power demand and capacity output. And at the end of the day, water, after rotating the turbine and the generator, we should evacuate that water using a tail race. The tail race return water back to the river after it exits the turbine, because this water should come back to the normal flow of the river. And we should minimize backflow and water logging at this level. And this is also when we'll consider maintenance, we are going to see how we can minimize this backflow and the water logging, mainly by cleaning the channel. So let's see now for hydropower. Once the turbine is running, it runs also the generator. It is compulsory that the speed at which the generator is running it should be constant. What means that the turbine should be also turning at a constant speed. And for the turbine to run at the constant turbine, it is compulsory to have given a constant amount of water which is heating the turbine. And we call that the control system. There is need of the control system, because if the speed is varying anyhow, at the end of the day, the frequency also will change. And this is going to create a problem. So the control system will manage the flow rate, the turbine speed, and electrical output. Electrical output, it's about the voltage, it's about the frequency. They should be constant. So the control system is include some automated sensors which have to see the water coming out, and they should be able to be manipulated or monitored from remote areas. This should be possible using the technology of Internet of Things. After producing electricity, a well-controlled electricity, let's say constant voltage and constant frequency, we have to transport this energy to where the energy will be used. And that one needs the transmission system. Transmission system is a electric line which is from the generator to the grid or end user. So we have seen that that's a big problem when we are using, for instance, wind energy, because wind energy is produced far away from the load center. This also sometimes is the case for hydropower. You produce hydropower far away from the load center. So at the end of the day, after producing energy, you need to transmit that energy to users. And remember, yesterday we are talking about conversion devices, because energy is basically produced in direct current. So we have to convert it, first of all, in AC current. And when you have an alternating current, now you can transform and step up that electricity to reduce losses during the transport, during the transmission. So after that, we have to see the power capacity and energy that is see after the site selection, after the demand. Now we have to see what the power capacity and the efficiency. So we have to optimize the efficiency of system, and for that one, we need to minimize losses. Which type of losses here? We are talking about head losses and losses during in the penstock. And this one is done by selecting very good right turbine and very good penstock, which should be done using very good material when you consider pressure, the amount of water, and so on. And the point which is important when we are designing hydro, I was talking about environmental and regulatory compliance. So at this level, it is a must. People, when designing this hydropower system, he has to do if he is able or to hire the service of someone who will do the environmental impact assessment. And this environmental assessment should be done before to give a go-ahead for the project. So we need to do that to have a permit for water use, consumption, and to have land access. So this environmental impact assessment should consider land access, should consider water use, should consider needs of the population. And we have to see, because for sure, when you are set up a hydropower, you have some impact which should be mitigated. And we know how to mitigate some impact. And impact which will be mitigated, they are mainly on biodiversity, they are mainly on sediment flow and water quality. Remember, at the first time, when we are diverting water, we should leave 8% of the total amount of water for the biodiversity conservation. So this is a simplest scheme of a hydropower design. The first part of it is the deviation, the four bay. This 4 bay can be used, or we can also use a dam, because the role of this 4 bay is just to store water, is a reservoir. We can also use these 4 bay, they are done like basins. It's a series of 3 or 4 basins. And the first basin will be used to stop floating material like leaves and other sediment. Or if you don't want that, you can use a dam. You store a dam there, and if dam is stored, you make a screen at the end of the dam or the 4 bay for debris, to stop debris, and now you can go into a penstock. The penstock takes that water to the turbine, which is in a house, which we call a powerhouse. In the powerhouse, you have the turbine, you have the generator, and you have the control system. And after running the turbine, water is taken to the lake or to get again the river. This is the simplest way of designing it. But keep in mind that you have 2 parameters. The head should be there and the flow. So how to estimate the power? Remember, we know for sure that power is given by the product of the head and the flow. And you have to multiply it with gravity acceleration. And from power, we can get energy, by multiplying power by the time you are using it. So the head, how we can determine the head by the plant by using a stopwatch which is available on any shop or on any phone. So if you know the time and if you know how to compute the head of an object under gravity, you just take a piece of stone, you take it at a high level, you let it go down, you get a stopwatch which will give you the time it takes to go down. And to get the head, you have 1/2 g t square. T is the time you are going to record, and g is the gravity acceleration, which can be taken at 9.8 or 10 in some cases. And we have also to measure the flow. The flow is determined using either a bucket method or a floating method. The bucket method is the time we are taking to fill a bucket of a given volume. If you know the time and you know it takes to fill the bucket, you have directly the flow. Or you can use a floating method. The floating method, which consists of measuring the time a floating object takes to go from point A to point B, and you measure that distance between point A and point B. If you know the distance, you know the time, you can know the speed. If you know the speed, and you know the cross section can be measured using a tape. You measure the cross the river width and the section. Knowing the section at the end of the day, you multiply with the speed, you get your flow. So after getting the flow and getting the head, we can consider water density as 1, and you compute the power estimated times 10, and you multiply by the time, you have the energy. So what to consider when assessing the suitability of micro power? And that one is going to take me to the maintenance. We have been able to cover the design. To design, we have seen a number of factors coming in. We have seen a simple way of getting energy out of hydropower. You just divert water, you store that water, you have a penstock, which will take that stock, all that water with high pressure to the turbine. The turbine is going to convert the kinetic energy to the mechanical energy. That mechanical energy will run the generator which produce energy. So now let's see how to maintain the maintenance part of this module. So all starts with operation and maintenance program. This is the first box. The first box is you have two things to be done, to be considered. The first box is the maintenance. The second box is the aspect of management, because the system should do manage. And to manage the system, you have to consider a number of aspects. That's why we have to consider the management part, and we have to consider the maintenance part. For the maintenance part, you can see what you have to do a faulty analysis, which spare is not working properly. So you do the fault analysis. You can also do the maintenance scheduling. Let's say, for instance, to schedule maintenance, it can be in terms of hours, or it can be in terms of energy delivered. You can say, for instance, after 800 hours, I have to do a maintenance. You schedule maintenance at that level. Or you can say, after giving, let's say, 100 megawatt hours, I have to schedule a maintenance. So those are two elements of the maintenance. And we have three elements of the management. The first element of management, we need to do documentation. And you document the management, because you know for sure that these are spare parts which are almost are coming almost all the time in faulty way. You need also to consider the to monitor conditions, and finally you have to see the issue of investment and initial investment aspect. Because if the initial investment is too high, and if the maintenance cost is also too high, at the end of the day, you cannot select that system. That's why we have to consider all these. So coming to maintenance scheduling, we have about two types of maintenance. The first type of maintenance is corrective maintenance, and the second one is preventive maintenance. Corrective maintenance is done when there is a fault shown, and the preventive maintenance, you do it before the system is has breakdown. And finally, for the management aspect, we have here predictive maintenance. You predict, for instance, let's say I can schedule after 100 hours to maintain a hydropower system. And this means, this supposes that you have been able to store a number of spares, and number of spares to be stored. You have them after documenting the faulty, the system faulty which have occurred. So this is mainly the graph about maintenance. So maintenance now of hydropower plant. The first one is routine maintenance. So you do it in routine way. And for routine maintenance, what do you have to maintain? You have to do regular inspections and activities to keep the system running smoothly. This is using, for instance, you use oil or lubricant to make running system run properly. So we have also how to maintain the intake system. The intake system is mainly maintained by clearing debris, by keeping levels of water, and by seeing sediment. We have to remove sediment. And this sediment, mainly you have sands and other sediment which can deposit from, and this one, we can do all this from the screens and trash rats. So at the level of intake, this is mainly the maintenance to do. You remove debris, you see water level, and you remove sediment. And you can also monitor water level, because if the water level is down, you have to increase that water level by using either a solar pump when it comes to the need of 2 reservoirs. We have seen that system, it can be used. So for the penstock, the maintenance to do is mainly checking for leaks. If there is no somewhere water can be lost. So this is the main maintenance you have to do on the penstock. You check for leaks, you check for corrosion, and you check for flow blockages. If there is something blocking water to flow properly. If you see something which has been inside, you just remove it. Or you see if there is a corrosion, you just work on that. And you check if there is no leaks. If there is no leaks, you just close it. And at this level, you have also to inspect joints, because penstock is made with different parts. Otherwise, it will be too heavy to transport on the site. So you have to inspect the joints, and you have to inspect the supporting structure to prevent failure of this system. So we go to the turbine, because we have seen after the penstock, water is taken to the turbine. How do we maintain turbine? To maintain turbine, we do lubrication of bearings and moving parts. This is a big problem with hydropower, with wind, because we have parts moving. But this, you will not find it when using solar, because in solar, you don't have parts moving. So the first maintenance is about lubrication of bearings and all moving parts. And if they are faulty, you have to replace them. You have to inspect cavitations, let's say turbine blades. You have to see how blades are and where, if possible. And finally, for the turbine, you have to balance the turbine to avoid vibrations. So you see the way it is fixed. If it's no longer well fixed, you close, you tighten those pieces which they fix it. So after the turbine, we see how to maintain the generator. To maintain the generator, you have to check for electrical connections, you check installations, and you check output voltage using a device, because we have seen that the voltage should be maintained constant as well as the frequency. You have to lubricate bearings and cooling systems. These should be maintained when coming to a generator. And finally, for the generator, we have to to avoid overheating of the generator or misalignment. This one you fix very well, tightly, the generator on a structure. So you have the last part, not last because the tolerance will be also and drainage will be maintained. We have to maintain also the control system. The control system which is in charge of making sure we have a constant voltage, a constant water coming in the turbine, a constant frequency and so on. So for this one, you have to see calibration of sensors and control unit, because this control system is full of sensors. So you look sensors, if need is, you set them very well. And at this level, you have to inspect automation systems and for faulty or power charge, you have to do this inspection of automatic system. And finally, for the maintenance of the hydropower, we have the maintenance of drainage. For this one, we have just to clean sediment, sediment which can be there and avoid the build-up of those sediment. That's why we need to clean them, and you have to see if there is no obstruction to maintain the flow of water to the river or to the lake. So these are mainly things to do for maintenance of different parts of the hydropower. So let's now, this is about routine prevention. So this you do it in a routine basis, but you can also do some preventive and corrective maintenance. For that one, we have to schedule maintenance to prevent equipment breakdown, or you have to replace or component which they get problem all the time. And at this level, you see mainly bearings or electrical parts or seals, and let's say all moving parts. Those should be repaired or simply replaced. You can do cleaning and repaint parts which are prone to rust or to corrosion. These ones need to be repainted or to be cleaned, because if you have corrosions, it may end up by consuming a metallic component. We have to repair leaks if there are leaks in the penstock or cracks in the SIVO structure. If there is cracks, you just do another, you prepare, let's say, cement, and you do concrete, and you repair if there are some cracks. Or if a part is faulty, you just replace that part of penstock. That's why it should be done in part by part, instead of doing that a single object. And we have to realign the turbine or generator to restore optimal efficiency. So these are mainly the maintenance we can carry out when coming to hydropower. And we are going to do the same thing. I would like to say these are maintenances to be done for hydropower, and we have to consider also the same way of designing and maintaining as a renewable system. And at this level, we are going to see how to go about wind. And for wind, Prof. Majaliwa will cover that, and I'll come back to cover solar maintenance, solar system maintenance. So, Professor Majaliwa, over to you to cover the wind system.
Okay, thank you, Prof. Karume. Thank you once again. You know, just to tell the participant that Prof. Karume has just been operated. His eyes were operated recently, so I'm very happy that he actually is recovering. The way I'm seeing is actually recovering. Now, so let's talk about wind. So as Prof. Karume said, there are a number of things which we need to consider, as we did for hydropower. And in this case, we are looking at the site assessment. Remember what he said, site selection, the power capacity and efficiency, the environmental effect, but also the scale at which we want to establish some of these projects. So in terms of site assessment, it's very important that we select our site in order to maximize the potential energy of the wind and minimize the cost of installation of the project. So for us to do this again, as we did for hydro, is basically to also assess the wind resources. And for someone to assess the wind resources, we need to know the wind speed, the wind direction at every location where we want to establish our project. And we need to check the consistency. Mondo, can you switch? Mondo, kindly. Can Mondo kindly close the microphone? So we need to check for consistency over time. Then you have to go into the climate information and check how the wind speed have been behaving for the entire climate period. So as we said, wind speed for producing energy is adequate from 5 meter per second to 25 meter per second. So we need to cross-check if the magnitude of our wind speed is within the range of adequate wind speed. In terms of topography, we need generally to look at flat area or gently rolling. Gently rolling, these are slopes of 2 to 8, at least 2 to 8% on the landscape, and then minimize any fluctuation of the wind direction and speed. And this is basically linked to obstruction we can actually get around our project area. So we need to check of building, we need to look at trees, and if how the hills, the pattern of the hills, which can actually affect the wind flow. Sorry. So we also need to look at, in case we are looking at integrating our energy into the grid, then we need to look at the grid accessibility. If you really need to sell it to the grid or use a mini grid, so you need to see the accessibility and how much this will cost to actually make the integration effective. We also need to look at the land use. As I said, because we need to maximize our output, so we need to look at all those factors, as I said, could create fluctuation in the direction and the speed of the wind. But also consider the environmental impact assessment. So for every project anyway, you still need to do an environmental assessment for compliance or for compliance's reason. Now, we also look at the type. What are the type of wind system we want to put? Is it with horizontal axis or with a vertical axis? So this will define, of course, the type of tower, which is the stand on which everything is going to be fixed. The nacelle, which actually is the box where you have your gearbox, you have your generator and the brake system, but also the yaw mechanism, which assists you to check the direction of your rotor. And then, of course, the rotors and blade. The rotor basically the one which, through the movement of the blade, generate for you the kinetic energy, which is going to be transformed into electric energy. But then we need to look at also the electric system, basically where the transmission system, because there we have the electrical wire and lines, you have the transformers, you have all the wiring, all the inverters in that particular electrical system. So we need to check those on. Then we have the control system. In the control system, that will also control the speed direction, the speed magnitude, but also maintain the performance of a turbine in an optimal way. For the tower is fixed, there is a foundation to maintain, to make sure that we have stability of our system. So someone has to look at the foundation, but also the transmission system, which take the energy generated into the grid or to the end user. Now, we need also to think about the layout. The layout, again, here is basically to make sure that our system is producing electricity in an optimal way. So that will be taking into consideration the spacing between the different stands, the topography, the wind direction and magnitude, but also the land use, as we say, around it. So whatever was said on hydro for the different component is also valid for wind, especially when it comes to the rotor, the control system, the gearbox, the generator, and grid connection. What we said in hydro still valid in this case. But now, what are the routine maintenance required? So these, as Prof. Karume said, these are regular operations which are carried to make sure that the equipment is still safe and give us sustainable energy output. So we look at all those moving parts and we make sure that they can actually, the frictions are reduced. So you need a lot of lubrication to assist in that, and that will be there for the gearbox and all the bearings. But you need also to check if the bolts for the foundation, the bolts in the gearbox, the bolts in the nacelle are well fixed, so that the system remains stable. So you need still to inspect the blades and see if the blades are still intact. Look at the tower, if the tower is still stable, and if the electrical system is still working properly. Then in terms of preventive and corrective maintenance. Of course, as he said, this is basically through fault analysis and basically maintenance schedule and monitoring the conditions of the different parts. We need to look at if the gearbox are still okay, if the generator is still working properly, and if the control system is also working properly. So you need to check for the blade if they have cracks, if the foundation is affected by erosion, if you have a lot of debris which are built up around the foundation. But also you need to check the yaw mechanism check, because that's more important to maintain the frequency of the rotor within the range. Can someone close Samir, please? Can we close Samir? Samir Coco. Can Coco is absent and is just there making noise for us. Can someone close Coco, please? Kato, where are you to close Coco?
ده خلط شوف هناك يا سمير.
Samir, can you close? Can you mute?
ما في بقول لك يا
Ekebu, can you
ميزانية التقديرية
Ekebu, can you remove Samir, please?
والصفرية أساس.
Yeah, thank you very much. He will come back, but then he will learn. So then you have to do some supervisory control and data acquisition because this is the documentation part Prof. Karume was actually talking about. So we need to monitor in real time the turbine performance. Data should be collected all the time from output, from the output from our turbine. We need to track regularly the wind speed, the direction, and what is coming out of it. We need to check all the different components if there is no fault within the different components. And if there is any fault, then we should actually create an alert for people to be able to solve the issue. So I think that's Prof. What I could say for the wind. So you can move ahead for the solar energy.
Yes, coming to our renewable energies, after power, after wind, covered by Professor Majaliwa, now we can see what is all about solar. Can you go back to the, Prof. Majaliwa, go back to this figure? Yes, Prof. Majaliwa, okay. So the system which is shown on the screen, it's a very big system. As you can see, you have a number of solar panel, and it can cover even 10, 15 hectares. But why I'm showing this? This is not a usual solar system. This system, you see, it has a tracking system. The tracking system allows solar panel to move and follow the sun. And the maintenance of this solar system becomes different from a regular solar panel, because here now we have moving parts, but in solar generally we don't have moving parts. I'll come back to that when it will be. So now design of solar system. Can go ahead, Prof. Majaliwa. So we proceed the same way. The first thing in site assessment and feasibility study. For site assessment, we have to assess if solar resource is available. And we have seen, being in Africa, on the continent, when you see the map, you can realize that almost everywhere in Africa, it is possible to get a good irradiation. So at this level, we use maps and we analyze sunlight hours. These maps are available, and if they are not available, you can make them. You can make them using softwares. Softwares like GIS. GIS can help you to make a map of solar irradiation from data obtained on meteorological websites. And these data, they are free of charge. So you can use softwares like PV GIS, OMA, which are these softwares, they are available, and you can make use of them. And from those softwares, you can also see what is the peak sunlight, because to know the potential of sunshine, we need not only to have sunlight hours, which is the solar irradiation, but we need also to have peak sunlight hours to be able to see if the site is well appropriated to produce energy, solar energy. Secondly, on site assessment, we have to do some land analysis. Is the land available? As I was saying, we have two types of solar system. We have solar system using very small amount of land, and we have, as it has shown on the figure we have seen, a solar system which is using big amount of land. Sometimes it can be even 50 hectares, and where you are using a tracking system. So you have to make sure that land is available. But generally, for small systems, we have seen that the system can be mounted on roofs or on can be integrated on the house. So if the house is there, you see the land will be considered as the roof, or the house which will be integrated with panel solar. So you do land analysis to analyze to identify if power requirement can be met. See, if you have the demand is too high, it means you need a big number of panel solar. And of course, this means you need a big amount of land. For household irrigation and simple applications, you can use the roof or integrated structure. Secondly, we need to see space availability. If after computing, I see that I need 5 hectares, I should make sure that this space is available. If the space is not available, I have to find a way or to abandon the solar system and see if there is another renewable resource available. So you assess the area for panel installation. And this is a function of power demand. Sometimes you can put it on the ground, that is a ground-mounted system, or you can put them on the roof. This is a rooftop system. You have to ensure that no shading from trees, from building, from a hill terrain, or any objects which can create shadings. And I have emphasized enough that this shading will not cover a part of solar panel, because if only a part of solar panel is covered, this is too bad. Better again to cover the whole panel than covering just a part of a working panel solar, because it will break down. So we have to check for that. If trees are around, you cut them, and you make sure that solar is coming directly to this solar panel. And sadly, you have to check the budget and do some cost analysis. For the budget, you have to see what the investment cost. Investment cost depends on a system to mount, depends on energy demand, and we have to do some cost analysis. You see if the money you invest can be recovered and how long. And when we are going to discuss that economics part of this issue, we are going to see the duration of the system is 25 years for solar panel, 7 to 10 years for converters, 10 to 15 years to batteries. And all those should be considered when you are doing cost analysis. So you estimate cost for component, for installation labor, and for maintenance. The good thing when it comes to solar, the maintenance cost is too low because no moving part. So when it comes to tracking system. So after that, you conduct a feasibility study, and you determine if the return on investment can be done. So if that is well done, so you can now proceed and go ahead. So what are components of solar system and how can we maintain them? The first component is solar panel, which is a photovoltaic module. This is a fundamental part of the system. So you have, first of all, a mounting structure, which is a system which supports solar at the ground, and you have to put them at a correct angle for maximum sunlight exposure. Yesterday I said this angle, the tilt should be between 2 and 15 degrees. So when you are at the equator, you have 2 degrees. You cannot take it flat. Even if the solar is heating, there's a panel at 0 degree, you have to take an angle, a correcting angle to allow self-cleaning of solar panel when it rains. So after that, we have inverters which convert DC direct current electricity from solar panel into alternating current electricity for use. But remember, sometimes we don't need these inverters. If loads are appliances are direct current users, you don't have to use inverters. But when it comes to on farm, you have a fridge, you have a lighting, you have a radio, you have a television. So you'll definitely need to use an inverter. So this is the second part of the system. So we have about 3 types of inverters. The first one is a string inverter. This is cost-effective inverter for small systems. So when you have small system, you can use the string inverter. But we have also another type is a micro inverters. The micro inverters is mainly used when it comes to advance to each panel, you have to use it to each panel for high efficiency. And finally, we have the hybrid investors, which are the most used. They allow integration with batteries for energy storage. These hybrid inverters are very good because not only you connect the solar panel to batteries, but you can also connect the grid to the batteries or a generator to batteries, because when sunshine is not there or the system can have some fault, you can use the generator, let's say for about 2 hours. During that time, not only use electricity from generator, but at the same time you charge your battery. And these hybrid inverters, they are well indicated. So finally, we have energy storage, which is optional, but very important, because when you need to use energy during no sunshine time, you need to use storage. As is storage, they are mainly constituted with batteries. And in the past, you have lead batteries, and today we are using these batteries, lithium batteries, which are most effective and they can last long, though they are now a bit expensive because the technology is new. So batteries should store excess energy for use during the night or cloudy time or days. So when you design the number of batteries to put, some people can consider 2 days of rain or 2 days of cloud to make sure that during the 2 days, even if there is no solar, so there is no sunshine, you can still use your system. So after 2 days, if the sunshine is not there, now you have to use the generator to charge your batteries. But they should be sized according to this principle of 2 days of cloudy days or when there is rain occurring. So at the end of the day, we have also charge controllers. Why do we have charge controllers for batteries-based system? Because these charge controllers, they have to regulate the voltage and current to prevent overcharging and deep discharging of batteries, because overcharging and deep discharging, they kill batteries. And overcharging is very bad because it may induce, it may bring fire and can burn the whole house or the whole system. So we have to avoid overcharging to make the system safe. And we have also to avoid deep discharging to make sure that batteries are working properly. So the type of charge controllers which are used today, we have the PWM, which are cheaper but not very efficient, and which are mostly used, they are MPPT system. These ones, they are more efficient and they are usually used in the system. So balance of system. We have to include cables, to include connectors, fuse, circuit breakers, and we have to see switches and junction boxes, because all these should be considered when you are designing the system, and these ones should be also considered when you are maintaining the system. And you have finally a monitoring system. This is you have a track system, performance, energy, production, and you have also fault detection. Today, with the technology available, you can have all this on your phone. So the system can send you this information on your phone. So you can know on your phone. You can see wherever you are that what is happening with your system. And mainly when it's an industrial system, you can see the level of batteries, the level of charge, the level of how the system is working, what's the current needs, and so on. So, according to the demand, that one you get it at the community level, at the household level. So system siding. For this one, you determine the number of panels, solar to be used, the number of battery to take into account, considering that you can have 2 days of no rain. And all these, you have to compute them according to energy demand. So if the demand is high, the number of solar panels should be high, the number of batteries should also increase. But if the demand is very low, the number of batteries and panels will be taken accordingly. And remember, you can also see all that when you are in the region where the sunshine is not too high, you can also increase the number of solar panels. So we said we have to see the tilt and orientation. Why tilt and orientation? Tilt to make sure that solar panel, they are self-watching. So tilt panels at an angle equal to the, let's say, to the site. And I said, for instance, at the equator, it should be 0 degree, but we have to take 2 degrees to make sure that this solar panel, they are self-washing. And to optimize energy generation. Because if the tilt is not good, you are going to heat, the solar is going to heat your solar panel for less time. But if the tilt is very well, you also prolong the time the solar will be heating your solar panel, and so you maximize your efficiency. So often a panel, let's say, you have to orient your panel solar toward the equator. So it means when you are at southern hemisphere, you have to take it north facing in the southern hemisphere. So this is how you have to set your solar panel. So now energy storage saving. It's about batteries that I was saying. This, you have to calibrate, to calculate the battery capacity to make sure that power is available during off-sign hours and during 2 days, 3 days, depending on your application of cloudy days or of rain.
Mais c'est pas ce que
We are,
la liste de présence.
as we are saying, at the end of the day, we have to see the grid integration, because the supplies of energy, if all the energy is not used, you have produced more than what is needed, you have to interconnect to sell the additional energy to the grid. So you design the system to connect to the utility grid for making some money. Don't forget that this course is about powering economics of farming, of farmers. So farmers can get money out of their renewable energy systems to make sure they have a regular maintenance and they get money out of that. At the end of the day, you have to carry out environmental impact assessment. So we have to consider environmental factors. You design to make sure that dust, temperature fluctuation, and the wind loads are taken into account. Because if you are on the area where wind is too high, it can take away the system. So you have to fix this system very well to make sure that wind cannot take them away. So how do we maintain a solar system? To maintain a solar system, as we are doing, you have to do routine maintenance. Routine maintenance, they are performed periodically to ensure the system runs efficiently. And mainly for solar panel is cleaning, visual inspections, and software monitoring. For solar panel, the most maintenance which is required is cleaning solar panel. Otherwise, your system is going to reduce its efficiency. But you can also carry out some visual inspection to make sure that the cables are well fixed. And you have also to see if the software is working very well. That's why you have to monitor it. Things which are today very good, you can do all this using your phone. Wherever you will be able to do this software monitoring. You have to do some schedule check to prevent faults and improve longevity of your system. So we have to do some inspection of electrical component for wear and tear, and you have to ensure that the connections are tight and corrosion free, and you have to do some repair or replace faulty component such as panel. We have seen inverters can get some problems, and you have also to check if the batteries are well. Otherwise, you have to replace them. Key maintenance activities for solar panel is mainly clearing dust, and bad droppings, and debris should be reduced to make sure that the energy output is good. So this is the most important part of maintenance: clearing dust, clearing that things, clearing bad droppings, and so on. And remember, if you have trees around, you have to make sure that you are cutting branches of those trees to avoid cloud, or to avoid panels to get problem. Panels should be clean using soft brushes. Never use a metal brush or something hard. And you have to use water without detergent. Sometimes you usually use water, you don't have to use soap or any detergent. And no abrasive materials should be used when you are cleaning your panels. So make sure you do it at the frequency of every 3 to 6 months, depending on the site where you are, because the level of dust changes with site. So you have to see if there is too much dust, you do it after 3 months. If there is less, you do it after 6 months. Otherwise, you do it between 3 and 6 months. You have to do regular clearing of to prevent dust building on a solar panel, and so you are to reduce is giving very small amount of power. You have to keep inverters, and you have to monitor system, updated the software to make sure that it's performing well. And you have to replace some component. When components are faulty, you replace them. And for inverters, you can go up to 10 years, 10 to 15 years. For batteries, 5 to 15 years. For other spares, you have to consider their lifetime and to change them. And let me end with this slide. This slide is showing when it comes to maintenance. And if you have a roof mounting system, you can do maintenance. You go up to the roof, you disconnect the system, you use water, and you clean your solar panel. If you have a ground mounting system, as it's shown here, you don't need to climb. You just disconnect the system. Please disconnect the system before you maintain the system. Otherwise, you are going to create problem, and you kill your solar panel. And in some areas where security is not key, let's say in some area sites like today in the Congo with the war coming, or the war going on some areas, you cannot leave your solar panel at the roof or outside. People will come and steal it. You can use a mobile object to make sure that you can take it outside during early day, early time, and when sunshine has gone, you take it back home. See, so this is mainly what to do with solar panel, and I would like, but it's time maybe tomorrow, Prof. Majawiwa will continue with the geothermal system. Prof. Majaliwa, over to you.
Yeah, thank you, Prof. Karume. So we have only 4 minutes with us. Is there any question? But colleagues, we take Jolene, can you assist us to get some of those questions? And if
colleagues, if you have any questions, please raise your hand or type in the chat so that we can be attended to. For those who are asking for the recording, this session is available on our YouTube channel, Forum Network. You'll be able to see these trainings, the recordings. The slides for reference, yes, after the training, the slides will be sent to you. So, Prof. Majaliwa, it looks like we do not have questions for today.
Yeah, thank you very much. Then let's then again postpone the meeting for tomorrow. Then we can close.
Yes, so colleagues, thank you very much for being part of this training, and let's meet again tomorrow for the last day of the training. Thank you so much. Have a good evening.
Thank you. Good evening.
Thank you. Bye.
Bye.
Bye.